Hello everybody, Brian here from WCC. This month I want to discuss modern control systems for water treatment equipment and the various sensors used to make them work. Over the last decade, rapid advances in computer technologies have fueled a growing demand for intelligent water treatment system controls. Gone are the days of printed circuit boards filled with relays and resistors and capacitors and other hardwired logic devices. Here are the days of programmable logic controllers able to accept digital on-off signals, analog variable inputs, and coded SCADA inputs from building automation systems driven by BACnet, Modbus, or other protocols. Oftentimes, these PLCs are tied in with interactive touchscreen controls, also known as HMIs, or human-machine interfaces. The various components making up the complete water treatment system, such as pumps, filters, tanks, disinfection equipment, and more, are illustrated on the touchscreen in a sort of cartoon version. Touching the object on the screen often opens up menu options and diagnostic information for that specific component. The best part, if something in the logic scheme of the controls isn't working properly, it can be reprogrammed without having to replace or upgrade the control circuitry. Most of these PLC controllers also allow remote monitoring and even remote operation via a building automation system, an added bonus. In order to function correctly, PLC controls require inputs from various sensors in the system. Commonly used sensors include flow meters. They use paddle wheels, sound waves, or magnetic fields to measure and quantify the movement of water through the treatment system and the facility. They send back a variable analog signal, usually 4 to 20 milliamps, to the PLC. Flow switches. Similar, except that they only use an on-off paddle switch to make or break a circuit. It's a digital input, and it lets the PLC know if there's flow at all. Conductivity sensors. These probes mount in a T on the piping, and they measure levels of dissolved solids. They have 2 electrodes with a 1 centimeter gap between them. The sensor attempts to send a small amount of electrical current through the water from one electrode to the other. The higher the level of dissolved solids in the water, the more current it will carry. Readings are sent to the PLC via a variable analog signal. The PLC then translates this into microsiemens of conductivity, megohms of resistivity, or parts per million of dissolved solids via a mathematical formula. ORP sensors. These probes also mount in a T and are used to measure levels of oxidizing disinfectants in the water, such as chlorine, ozone, or chloramine. At their tip, they contain a sacrificial metal. This metal is exposed to the water with the oxidizing agent in it. The oxidizer facilitates the movement of electrons out of the sacrificial metal. This creates a small amount of voltage. A variable analog signal is translated by the PLC into a specific number of millivolts. ORP levels of 200 to 600 millivolts generally indicate good water quality and adequate levels of oxidizers. Oxygen-rich water will also register millivolts of ORP, or oxidation reduction potential. There are similar probes available that are specific to chlorine or ozone and can actually be calibrated to tell the PLC how many parts per million of the disinfectant is in the water. Other commonly used sensors include basic pressure transducers for measuring system pressure, UV light sensors which measure the intensity of UV disinfection, anti-flood moisture detectors, and tank level sensors, which can range from basic float switches to complex analog sensors using sound waves or water pressure readings. This is by no means an exhaustive list. For help in designing a custom PLC-controlled water treatment system, contact WCC today.